Next, now I'm going to explain the experiment number 8 of forward and reverse engineering. Our aim is to develop the train design system using a forward and reverse engineering. Here, the engineer is the profession involved in designing, manufacturing, construction, maintenance of product, and etc. etc. At a higher level, there are two types of engineering, that is forward engineering and reverse engineering. Forward is the traditional process of moving from high level to logical design, and the reverse engineering is to implementing the reverse to code. Reverse engineering can be viewed as the process of analyzing a system to identify the system component and the interrelationship, create relationship of the system in another form of higher level abstraction, create the physical representation of that system. Reverse engineering is very common in such diverse fields as software engineering, entertainment, automotive, consumer products, microchips, chemicals, etc. For example, when you buy a new machine to machine, you will be manufactured by that one was the assembler and it to learn to how to build and it works. A chemical company may use reverse engineering to defeat a patent. In civil engineering, bridge and buildings designs and copied from past successful things because to avoid the catastrophic failure. In software engineering, good source code is often a variation of others' good source code. They will be using a reuse the codes which was born. In some sense, designer give a shape to their ideas by using clay, plaster, wood, or some rubber. But a CAD model is needed to enable the manufacture of the product. Another reason for reversing is to compress product development time. In the intensely competitive global market, manufacturers are constantly seeking new ways to shorten lead time to market a new product. Rapid product development refers to recently developed technology and techniques that assist manufacturers and designs in meeting this. For example, injection molding companies must drastically reduce the tool and die development time. By using reverse engineering, a three-dimensional product or model can be quickly captured in digital form, remodeled, and exported for rapid prototyping, tooling, or rapid manufacturing. Following a reason for reverse engineering a part of product. The original equipment manufacturers are either unwilling or unable to supply replacement product. Original supplier is unavailable or unwilling to output. The original CAD model is not sufficient. The gain competitive benchmarks methods to understand competitive products, to explore new avenues to improve the product, to analyze the good and bad feature of competitors' product, to strengthen the good feature of a product. Some bad features of product need to be designed out. The original design documentation has been lost or never existed. The original manufacturer of product no longer products. There is inadequate document of the original design. The original manufacturer no longer exists, but a customer needs the product. The original supplier is unable or unwilling to provide additional work to update obsolete material or adequate manufacturing process. It is more constrained technologies. Forward engineering is the process of transferring a model into a code through a mapping to an implemented language. Forward engineering results in a loss of information because model written in the UML are semantically richer than any current object in the program language. In fact, there is a major reason why you need models in addition to code. Structural features such as collaboration, behavioral features such as integration can be visualized clearly in the UML but not so clearly from raw code. To forward engineering a class diagram, identify the rules for mapping to your implementation language or language of choice. Depending on the semantic of language you choose, you may want to constrain your use of creation. Here, for example, the humor permits you to model multiple inheritance, but Smalltalk permits only a single inheritance. You can choose to prohibit developers from modeling with multiple inheritance, or you can develop idioms with that transfer the instances. Use tagged values to guide implementation. Use tool to generate code. There will be a tool for generating the code. If you click on generate code, it will be get a generic code to the background. Use tagged values to guide implementation choices in your target language. You can do this at a level of integer class. If you need precise control, you can also do so at a higher level. So choose with collaboration of packages. Here you can go see the source code which was generated when the model was created. In forward, the class diagram will be like this, and the user is the class name. The next works contains attributes, and that down works is operations or functions or methods. Same like that, there will be inheritance of classes, and it can be three level with better levels. For reverse engineering, it will be straight away. It will be reverse. It will come up the from the database will be top, and user actor will be from down. Thus, this development of train design system using forward engineering is successfully done.